Algebra 2, trigonometry, graphing complex numbers. The way to graph a complex number, 3 plus 2i, notice that it has two pieces, 3 plus 2i. And we've seen now that that is the notation of a plus bi form. And the two pieces, the a part, the 3 is a real number. And so we have two axes when we graph complex numbers. We have a real axis, which is our 3, and then we have an imaginary axis, which is going to be our 2i. So it's almost like this is, instead of thinking of it as the x-axis, think of it as the a-axis and the bi axis. And when you graph a complex number, you actually don't get a point. You get what we call a vector. A vector. A vector is, it's kind of like in geometry, like a ray, where it has a beginning point and then an arrow pointing. This is what a vector looks like. And so to graph the vector of 3 plus 2i, what you first want to do is think about where the, I guess the point 3 plus 2i would be. And again, so we're 3 on the x-axis is over 3, and then bi is the y-axis, so that would be right here. Now, if this was an xy graph, it'd be the point 3 comma 2. But we're going to draw this as a vector. And so it's an arrow pointing to that location. And let me emphasize that arrow a little bit. I'm going to make it a little bit more apparent. So you see that. So it's an arrow pointing to the coordinate that would be made by doing kind of 3 comma 2. And so that's how you graph an absolute value number, or I'm sorry, a complex number. We'll see absolute value in a minute. So let me just do these other ones real quick here. This negative 5 minus 4i, well, that would be negative 5 on the real axis. So 1, 2, 3, 4, 5, and minus 4i on the imaginary axis would be 1, 2, 3, 4. So it would be this spot right here. And so the vector would look like this, right? And I should probably label it. I'm going to do that. Negative 5 minus 4i. And this one was 3 plus 2i. Okay, let's take a look at negative 1 plus 3i. That's negative 1 on the real axis and plus 3 on the imaginary axis will give us this vector here. And let me label it. Negative 1 plus 3i, and then one more here. So I'll do this one in black. 5 minus i is 5 on the real axis and negative 1i on the imaginary axis. And so that is 5 minus I. So really, you just think of them, like I said, 3 plus 2i. You think of the 3 as like the x-axis and the 2i as the y-axis, but you know it's really just like the 2, almost like the point. And then you draw a vector from the origin, starting at the origin to that point, with the arrow ending at these points. The second one wants the sum of these. So find the sum of negative 2 plus 3i and negative 1 minus 2i. And they want to graph the resultant on the accompanying graph. Now, the word resultant, that might be new for you. You're going to hear that again later. And this whole page, actually, this whole thing with graphing vectors, you're going to see vectors come up again later on towards the end of trigonometry. So it's going to be a while, but you will see some of this stuff come up again. You'll see this word again, resultant. And it's basically the result of adding two vectors together. So the result here would be negative 3 plus I. So plus 3i minus 2i. All right, so let me do this here. I want to graph each of these vectors. Now, negative 2 plus 3i, that'd be negative 2, and plus 3i would give you here. So negative 2, positive 3. So I'm just going to draw the vectors. There's negative 2 plus 3i, and negative 1 minus 2i would be negative 1 and minus 2i there. The resultant is negative 3 plus I. And I don't want to get into a whole lecture here on vectors and resultants and stuff like that. Right now, at this stage, you need to know how to add them together. You need to know how to graph them. You need to know quadrants and stuff like that, which I'll mention in a minute. But these are forces, and the resultant is being pulled towards the stronger force. And so we'll talk more about this another time. But let me label these negative 2 plus 3i, negative 1 minus 2i, and negative 3 plus I. All right, so that's enough for the graphing, except this one says graph the sum of, or the graph of the sum of these lies in what? So when you add these together, you would get 1 minus 3i, and they want to know what quadrant is that in. Now the quadrants, and this is something that's going to come up a lot again and again and again. You've probably heard them before, but a graph is cut up into 4 sections by these 2 axes. And so this is our first quadrant. We use Roman numerals, capital I for 1. This is our second quadrant. This is our third quadrant and our fourth quadrant. And 4 in Roman numerals is IV. And so they start here in the top right, and then it goes around in a counterclockwise fashion. So this says the sum of these, which is this, is in what quadrant? And so let's see. It would be a positive 1 and a minus 3i. It would be positive 1 minus 3i would be like that. And so this is quadrant 4. So the answer is quadrant 4. And you'll see a bunch of questions like this tomorrow. Just add them together. What quadrant is it in? All right, and then number 4, the absolute value of a complex number. This is probably the trickiest part, and it's not too bad, of this whole thing. Now, first of all, absolute value in general is all about distance. Like when you see the absolute value of negative 5 equals 5, the reason why this is a true statement is because you're saying that negative 5 has a distance of 5 from 0. And it's true. If you look at the number line, and you see negative 5 here, 0 would be over here, it's 5 away. And that's really what we're talking about when we talk about absolute values. How far are you from 0? In this case, it's how far are we from the origin. Like if we go back and look at one of our graphs here, find a good one, like this one right here, how far is this from the origin? And so like if I did the absolute value of that, that would be my way of asking you. The absolute value of negative 5 minus 4i is how far is this point from the origin? And basically what we do is a version of the Pythagorean theorem, because I could turn this into a right triangle and count boxes for this number and count boxes for this number and do a squared plus b squared equals, you know, c squared here, and then solve it that way. And so that's basically what we're going to do. That I know that I'm 3 away on the x-axis, or the real axis, and I'm 4 away on that axis. Like if we were to look at it, this would be somewhere, you know, over here, where if I were to draw this triangle here, now this would be a vector, so I should have an arrow there. You'd be 3 here and 4 here. That would be at the point 3 plus 4i. So the distance is the Pythagorean theorem with 3 and 4. And so basically we have a formula. Let me give you the formula here. That the absolute value of a plus bi equals the square root of a squared plus b squared. And that part comes from the Pythagorean theorem, you know, is a squared plus b squared equals c squared. Well, if we just wanted to solve for c, we could do the square root of both sides, and then it's just c equals a squared plus b squared. So this is the Pythagorean theorem. And notice that the I dropped off, though. The reason for that is because if we square I, it becomes I squared, and that becomes negative 1, and then we're going to end up subtracting and stuff like that. And really, that doesn't matter. It's still a distance on a graph. So when you're doing these absolute value things, you pretty much just completely ignore the I part here, and just focus on the 3 and the 4. And so this would be the square root of 3 squared plus 4 squared. And you're going to end up with 9 plus 16 is the square root of 25, which equals 5. And so the answer here for this one is 5. Let's do one more. Absolute value of negative 3 minus 3i. So that's going to be the square root of negative 3 squared plus negative 3 squared. And don't forget, I'm putting these in parentheses because these are negative numbers, but they're going to square positive. And I'm completely ignoring the I. Negative 3 squared is 9, plus another negative 3 squared is 9. That's giving us rad 18, which can reduce down to 3 rad 2 for my final answer. So it's basically just Pythagorean theorem with these two numbers. Not too bad. All right, that's it.